Good afternoon, everyone. Very warm welcome again. My name is Brian from Orthman Manufacturing. Today we have a great lineup with some guys from financing and as well as guys from the US. So today, the guys that will be joining me today, Jaapie Vermaak from Standard Bank, South Africa. We've got Brian Olsen from the US, Bayer, and Willie van der Merwe from Bayer in South Africa. Mick Godeken from Orthman in the US. Gentlemen, very warm welcome. Thank you for joining us. I know this is a thing that's we've done now for the past 2 years, and I just personally think it's good to give information to customers and growers out there that will be joining us live today. And please, asseblief die mense wat gejoin is, sit julle hand op, as julle vrae het, sit net julle hand op en dan ons wil definitief, jy weet, vir julle kan antwoord. So feel free to just raise your hand, answer. We'll definitely want to answer some questions through the session. And yeah, what I want to do is I want to kick off with Jaapie. Jaapie, you know, yes, we're discussing, you know, strip-till in, jy weet, wat ons nou vorentoe doen, en ons is 'n premium produk. Wat is buite daar vir van julle as 'n bank, Standard Bank?
Firstly, Brian, thank you for the opportunity to just come and have this discussion. Looking at financing with regards to whether it's strip-till equipment or just any kind of other equipment, there is currently a misconception that within the Standard Bank Asset Finance Group, we only look after that stuff that's got motorized and got wheels that runs on the road. But we're a little bit more diverse than that. We look after various other functionalities on the farm and off the farm that we look to finance. A couple of these things include especially stuff like implements, mechanization as a whole. That's what we look after. The stuff that makes the run-of-the-mill work basically on the farm. So if we look at strip-till components or strip-till implements like Orthman as a product, we normally, I don't want to find it as vanilla, a product, but it is something that we used to and we do on a day-to-day basis, and there's various structures that we can build around this. So that misconception of just motorized equipment is unfortunately still there in the market. However, note that there is a wider range of things that we can finance, especially when it comes to implements or any mechanization that makes your farm go from A to Z from a production phase.
Jaapie, I know we had a discussion about, sorry, is there somebody who wants to answer something?
Yeah.
All right. So I know we had a discussion a little bit earlier on. Is there was a topic that you mentioned earlier on. Sorry, you're going to have to help me there.
I'm going to have to help you. So if I look, net so 'n bietjie ook in Afrikaans, as ek bietjie gaan kyk na finansiering oor die algemeen, jy weet, ons kyk nou na jy weet hoe ons die tipe dinge gaan finansier en almal gaan kyk vir hoe benader die bank gewoonlik finansiering vir 'n kliënt. So what we take into account is obviously there's some risk management we look at on the farm. You know, what do you do on the farm? What is the industry that you're on? What are the macroeconomics around it? And then we take it closer to what your finance position is. And there we take our interest in saying that, okay, a lot of people think that finance is a one-glove-fits-all, but similar to strip-till equipment, I mean, you just don't go buy an Orthman and everybody's got the same set of attachments on it. You're going to have people with discs, offsets, harrows, or rollers. At the end of the day, that's the exact same way we approach finance. So ons gaan kyk na die totale pakkie wat ons vir jou bied. Ons gaan kyk na hoe jou operasionele gedeelte is en ons gaan kyk na die komponente wat nodig is om seker te maak dat jou besigheid nog steeds bo bly finansiëel en dat ons jou kan help om hierdie toerusting te kan gaan finansier om jou besigheid na die volgende stap toe te vat. So for us, financing of equipment is not just looking at the equipment and keeping the equipment in the background of what we're going to get for it if something goes wrong, but it's more towards how can we look at this equipment, what is the total usage that you as a producer are going to utilize this equipment for, and then we take it into account, and then we start collaborating and negotiating the terms like is it how many years you want this on a finance program? What's the deposit size you have to throw in? How does it benefit your cash flows going forward, looking at the way your farming is going into the new era of financial sustainability at the end of the day?
Mick, I see you come on screen. I don't know, is there something you want to ask or say?
You know, how difficult, I guess, is it? You know, I'd look at some of the lenders here in the U.S. that guys really have to struggle to get approval, or they almost have to sign off their firstborn. So how difficult is it to work with you guys in South Africa?
So I guess from a finance perspective, we fortunately, I mean, during the COVID area, the one area, if we look at our current GDP that had showed a bit of growth, was the agricultural market. We've actually seen a massive increase with regards to asset sales. So we use SAMA, which is the South African Agricultural Machinery Association, as a yardstick to go and see, you know, what the units are that's going into the market. And we saw a nice 25% uptick year on year on agricultural units being sold. And in the finance space, we would thumbsuck estimate that 70% of that is financed through the finance houses here in South Africa. So finance is pretty easily available. There are quite a bit of competitors out here. Currently, fortunate for us, Standard Bank is the market share leader. And with that being said, I don't want to sound, but we've got, the wallet is open, especially on the agricultural side, because that is one space where we've got appetite and is currently going well for us. Even though our current forecast is that there will be a decline within the agricultural space in the GDP, what they add towards it. But if we look at what's happening on the ground, we've had good rains, the harvests are looking fantastic, and with that being said, the commodity prices are also staying stable and actually ticking up as we speak. So with that in mind, there's a little bit more meat on the bone all of a sudden, and that allows us to be a little bit more, how do I put this, friendly towards giving that finance required towards the end user.
Yeah, Yapi, thanks. I think, you know, that's great information. I don't know if there's something else you want to still share on from your end as Standard Bank.
No, I think Brian, at the end of the day, Orthman is a good product. People need to know that we look at it specifically as well. There's not much of manufacturers. In fact, there's no manufacturing on the African continent. We import all of our stuff, and it's determined on that rand-dollar exchange rate. And unfortunately for us, the rand isn't doing as well. Yeah. So the stuff is getting more expensive day by day, and that is where finance then comes into place. And we are cognizant of it, and therefore, I just want to say, you know, give us the test and let's see what we can do for you. There's obviously opportunities in the market, and we were happy to walk that journey with you.
Yeah, awesome. Thank you, Yapi, I appreciate it.
Brian.
And, you know, I want to move over now to Bayer. You know, I know time is, you know, we've got a time slot here, and please, as enige persoon is wat vraag het, of anyone that has questions, please raise your hand. We are willing to answer these questions for you. You know, we've got guys from Bayer here, and if there's any, you know, Mick, myself, we are definitely here to answer the questions where we can. So please, yes, feel free to send those questions, and yeah, we would like to answer them. Mick, I don't know, I know you guys have been doing some trials in the US with Bayer and Brian Olsen en Willie. Willie, ek weet nie, ek gaan dalk miskien net bietjie by jou kant inkom. Kan jy net bietjie dalk verduidelik oor die nutri of die wortel struktuur, waar dit is en waar dit was daai tyd en waar dit is nou en waar moet ons nou vorentoe kyk?
Yes, thank you very much, Brian. My name is Willie van der Merwe. I am in the market development team of Bayer Crop South Africa, and I want to talk to you about the efficiency of nutrient use. So, on average, an average of 40% of the nitrogen fertilizer applied to crops isn't utilized and could be lost. However, by making small changes to fertilizer use, farmers can reduce these losses and boost margins. In a normal season, most farmers will achieve a nitrogen use efficiency of somewhere around 60%. However, research has shown that 80% is achievable, and they believe this is what farmers should be aiming for. So what does 60% efficiency look like? Take a maize crop yielding 8 tons per hectare. This crop could have typically received 200 kilograms per hectare of nitrogen fertilizer. This crop has taken up 190 kilograms per hectare to support this level of output, and if you assume about 70 kilograms per hectare is supplied from the soil, that leaves 120 kilograms of hectare coming from fertilizer. This equates to 60% of the total applied. Looking at the benefits of improving efficiency in a situation when nitrogen is limiting yield, lead to increased output. If a farmer can increase uptake to get up to 9 tons per hectare, the efficiency rises to 72%. If nitrogen is not limiting, improving efficiency to 70% means the farmer can save on fertilizer and apply only 171 kilograms per hectare for the same yield. There are 6 areas where farmers can improve on the fertilizer use efficiency. Other nutrients, one is other nutrients, soil pH. A deficiency in another nutrient can lead to a lower nitrogen use efficiency. One example is sulfur, which has an important role in protein synthesis. A shortage in this macronutrient is linked with poor nitrogen uptake. Phosphate is also important for rooting, and having a good and extensive root network is important for maximizing nutrient uptake. Don't forget soil pH, as this also affects the root development. 2. Reduce losses to ammonia. Another factor hitting fertilizer efficiency is losses from soil. There are 2 key processes at work here: ammonia volatilization from applied urea and nitrate leaching. Aside from the environmental benefits of reducing ammonia, researchers believe tackling these losses can potentially save tens of kilograms of fertilizer and can be a substantial saving. Switching from urea to ammonium nitrate fertilizer is one way to eliminate ammonia loss, as it does not volatilize. Timing is important, and farmers should avoid warm, dry conditions when applying urea, as this favors volatilization. Timing is important. Number 3 is reduced nitrate leaching. Although nitrate is a very mobile form of nitrogen, if there is a growing crop present, it will take up the nutrient. Researchers say that leaching problem arises when there is more nitrate than a crop can take up during the periods of heavy rain and in winter months when the soil is bare. That is where cover crops can be valuable, as they can capture this nitrogen. Nitrification inhibitors are also useful, as they delay the conversion of ammonium to nitrate by about 6 to 10 weeks. And number 4 is apply the right rate. In season, farmers should be prepared to revise fertilizer rates up or down, and not simply stick to the original plan. Crop imagery and biomass measurements from drones and satellite PVI images, along with nitrogen sensors and tissue testing, are useful tools for seeing how crops are taking up nitrogen and getting better estimate of their requirements. And number 5, apply at the right time. Applying smaller amounts across more splits generally improves fertilizer use efficiency. One limitation to this is the weather. Go by conditions, not calendar date. The first and last applications are the ones at greatest risk of losses. The first dressing is key to get the crop off and running in the spring, but it is also the most at risk of leaching. So you need to ensure there is sufficient crop growth to ensure uptake, and monitoring soil temperature will help you with this. Conversely, with the last dose, dry soils with high temperatures can be a problem, increasing ammonia volatilization and reducing nitrogen uptake. Be prepared to pull the timing earlier if it is looking to be warm and dry weather. And then number 6, apply accurately. Finally, get your fertilizer applicator tested and ensure it is as accurate as possible. Poor accuracy can be a real problem. Technology is there to help the farmers achieve more accuracy. Now I will transfer to talk to you about the root structures. So roots provide essential functions, including the uptake of water and nutrients for plant growth, serve as a role of storage organs, anchor the plants to the soil, and are the site of interactions with pathogenic and beneficial organisms in the rhizosphere. The plasticity of root growth and development in response to changing moisture and nutrient status of the soil provides opportunities for exploring natural variation to identify beneficial root traits to enhance plant productivity in agricultural systems. The spatial distribution of all root parts in a particular growth environment is collectively referred to as root systems architecture. Root system architecture is a dynamic and affected by the external environment, the soil moisture, temperature, and nutrients, and the enclosing microbial communities that impact the way in which a plant detects and responds to its surroundings. Different root characteristics enable plants to respond, adapt, and thrive in different environments. An increasing global population requires agriculture production systems and cultivars that continue to be productive in erratic weather patterns and are capable of more efficient resource capturing from the soil. Breeding programs have traditionally focused on the above-ground plant parts. Breeders aim to develop improved cultivars that can tolerate a variety of abiotic stress conditions, such as drought and flooding. These approaches include selection of individuals with improved plant growth characteristics, such as grade or biomass yield, leaf surface area, and disease resistance. Strategies to implement root breeding require the identification of the underground root traits that enable a plant to more efficiently utilize water and nutrients in different environments. Multiple studies have identified links between root traits and crop productivity, including performance under drought and grain yield. Understanding the root themes that result in higher yields and increased stress tolerance would provide tangible targets for breeders to select individuals with the ideal root phenotypes to use as parents and develop breeding lines to advance through the crop improvement process. The key roles of roots as part of plant development has sparked renewed interest in understanding the molecular mechanisms that control root system architecture in crops. Strategies to understand root growth in root system architecture include forward and reverse genetics. The root system also contributes to soil health, which refers to the continued capacity of the soil to function as a living ecosystem that sustains plants, animals, and ultimately humans. Strategies such as crop rotation are beneficial because they disrupt pest and disease cycles, affect nutrient availability, and improve soil health. For example, the interaction between the root systems of legumes and nitrogen-fixing soil bacteria provide a plant-available nitrogen for a subsequent crop grown in the crop rotation system. The result is a reduction in the use of chemical fertilizer via implementation of more environmentally friendly and sustainable farming practices. Plant roots also keep the soil in place, reduce water leaching, and soil erosion. Breeding efforts that select for and modify specific root traits are limited despite the importance of the root system for enhancing the acquisition of water and nutrients. Genetic gains in grain production are important targets for plant breeding programs, and these gains could be enhanced by understanding the root traits that contribute to improved plant performance. The distribution of nutrients across different layers of the soil and the availability of these nutrients in different environments make the root system architecture a fundamental trait for resource acquisition. In soils with limited nutrient availability, intensive fertilization is often used to maximize biomass and yield. This approach is expensive for the grower and may result in nutrient leaching into ecosystems. More efficient fertilizer uptake is needed to reduce the negative impacts of fertilization, and this can be achieved by using genotypes with roots that are more efficient at capturing nutrients in the soil. Nutrient and water deficiency can also change the ratio of growth between roots and the above-ground plant organs. Changes in the development and architecture of root systems in response to stress conditions, such as water limitations, can be used to identify links between the molecular mechanisms involved in sensing and transducting to the plant signals mediating these changes. Roots sense and respond to abiotic and biotic stresses, and are able to communicate with the above-ground plants via signaling pathways. Research areas of practical value include identifying root traits that increase the capacity of soil foraging for water and maintain productivity during limited water availability. There are 3 important factors to look at.
Sorry, I'm gonna stop you there, Willie. There's just a couple of things here that I want to point out here before we get too far into it.
Yes.
Mick, I know you and I discussed this on the first day, and I'm just going to go back to your first question that we had actually, Willie, is Willie just brought out something very interesting about the right rate, the right place. These are the 4 R's that we've always been concentrating in. Am I correct, Mick? Mick, you on mute. There we go.
Absolutely, Brian. These 4 R's, we've been trying to follow the 4 R's for a long time, and we've discussed this, on Monday and trying to get better. Certainly, improving nutrient use efficiency is a goal for any producer around the world. So, that's our goals.
Willie, sorry, I didn't want to interrupt you there, but yes, you can carry on, and then just another a minute or so, and then I want to move over to Brian Olsen if possible.
Perfect, thank you, Brian. So there are 3 important factors to look at. It's the rooting depth, the root hairs, and root branching. So rooting depth is one of the most frequently evaluated traits because crops with deeper roots have better access to stored water and nutrients such as nitrogen, a soluble nutrient that tends to leach into the deeper layers of the soil. Although rooting depth is strongly influenced by the soil's physical and chemical properties, recent studies have uncovered additional factors that impact rooting depth, which could be exploited for crop breeding programs. Most notable are the anatomical traits in which a strong correlation between a specific type of root anatomy and plant performance under stress has been demonstrated. For example, maize genotypes with reduced cortical cell file numbers and large cortical cell size have deeper root under water stress conditions because of the reduced metabolic costs associated with soil exploration. Root hairs are single-cell projections that emerge from root epidermal cells. Because root hairs account for a large percentage of the total root surface area, it comes to us no surprise that they contribute to almost 50% of water absorption by the plant. Then lastly, root branching. The formation of root branches or lateral roots is a significant determinant of overall root structure architecture. Lateral roots add to the total root biomass, total root length, and root surface area. As such, it has been assumed that increased lateral root density is associated with greater nutrient water uptake. However, like many other root traits, the ideal lateral root density is dictated by the nutrient and water availability of the soil. So, drought, low soil fertility, and soil-borne air diseases are among the most widespread challenges for agricultural productivity on the global scale. Breeding crop plants for specific root themes, deeper branched, and retrospectively plastic, that are capable of adapting to variable growing conditions could improve water and nutrient acquisition, result in sustainable plant yields, and improve soil structure and soil health. Thank you, Brian.
Thanks very much, Willie. I appreciate that information. And, that's a lot of information that we do ourselves. Mick, the root structuring, nutrient absorbment, uptake in plants, all that information, it works hand in hand with our product. Mick, I don't know if you want to take over from, and then I know you and Brian work a lot there in the US with trials, and I don't know if you guys want to maybe just share from information from your end between you guys.
Well, Brian Olsen with Bayer Crop Sciences USA. Brian has some really exciting news he wants to share in regards to some Statute corn and how that's a little bit different than what we're used to seeing in some of the advantages of that. And I guess, Brian, I'll let you take it from here. And I know you've got some slides to share. So
Yes,
with that, Brian.
Yeah, I do. It says host disabled participant screen sharing. So if I could get that so I could share my screen, I'd be happy to do that.
All right. You should be able to share it now.
Yes, I can. Thank you very much.
You're welcome.
All right, and let me know when you see my screen here.
Yep.
All right, and typically I'd have my video on, but as I was telling Brian and Mick here, I woke up and it wasn't working. So that's the way it goes with technology. But trying to pick up on what was being said about nutrient management. So I think when we dive into the short smart corn system, you're going to find some interesting things about nutrient management. And then also roots, we're seeing some things there. And so this is going to be a different type of system that we're going to have out for farmers to use. And this is actually a picture out here in western Nebraska. So that's where Gothenburg is located at. And if you guys are familiar with green snap or lodge corn, we actually do some ratings with a helicopter to simulate that. And I always find this interesting when we think about testing our germplasm. We're using a helicopter to simulate those wind events. And so,
Sure.
Again, a smart corn system powered by short corn hybrids. So what does that all mean? So we've got a forward-looking statement here. Obviously, we plan to come out with these products in the near future, but things can happen. And also just want to highlight overall, we have a very robust pipeline, okay? And so there's a lot of innovation coming out of Bayer over the next decade. I think that's really important. Some of these products will be down in South Africa, but regardless, we have a very robust pipeline that will be there to find solutions for our farmers to help them improve their production system. So what is short-statured corn? So if you've got your regular tall corn product out in the field, and let's say it's 2.5 to 3 meters tall, maybe if I'm doing my calculations correctly in my head, what we're trying to do is basically put that down around that 2 meter height, okay? And then we're having that ear placement about 60 centimeters off the ground or higher. So we're shortening that overall plant architecture up. It has the same number of leaves, but just a shorter stature out there in the field. And so this is actually a wind event that occurred in one of our breeding trials. We got a lot of germplasm out there. We got short-statured corn and tall corn. And, the short-statured corn was standing tall. And then you'll see as soon as we get to the tall corn, it starts getting launched over. And so we've got 3 different ways that we're coming to market potentially with this short-statured corn system. And one is the breeding trait. So there is a breeding trait out there that we can implement into our germplasm that will shorten up those internodes. And then there's a biotech trait that we're working with BASF on that has, I'd say, a little more consistency. It's not driven so much by the environment, but it also comes at that shortening up of the internodes a little bit differently. And then genome editing, and that's a new one that's in the discovery phase. And so, again, it has the same number of leaves. And when we're just talking about shortening up, and so if we think about ear placement, right, and that node length, that internode length, we're just shortening up those nodes. And so we have the same number of nodes, we have the same number of leaves, but the overall architecture or stature of that corn out in the field is less. When wind events come up, that can play a big part on how that corn lodges or green snaps. And so you can see that this is going to be a global launch here. And so we've got South Africa highlighted where we can see some potential benefits. It's really back to what you were talking about, the nutrient management, potential water use efficiency, and precision of crop protection applications. I think it can have some real value for farmers down in South Africa. So protection from crop yield loss due to increased tolerance to lodging and green snap. So again, green snap is when you've got an ear of corn, or excuse me, a corn plant that snaps below the ear. And when that happens, as we all know, that corn is not going to produce anything, and we've lost that the yield potential off that plant. Well, obviously we want to minimize that. Lodging, if we get lodging close to harvest, it can cause all sorts of problems, can slow down the combine going through the field. And so we want that corn to be standing tall, right, throughout the season and not have any problems. You can see here access all season long for more timely, precise applications. And then yield potential through increased opportunity to optimize crop inputs, plant density, and field placement. So again, this is another visual for you. So 90-mile-an-hour wind, that's going to be somewhere in that, it was in that 140 kilometers per hour. And so pretty significant wind event that came through. And then again, the short-statured corn is standing out there compared to the rest of the corn products in the field. And so access to short-statured corn will enable all-season access for more timely and precise application of crop inputs. So a 36-inch toolbar, so we'll just say a 1-meter toolbar that you might typically have out in the field. Over here, we've got the tall corn represented by the orange line, and the blue line represents the short-statured corn. And what you see here is that days after planting, you basically gain an extra 7 days of access in the field with the short-statured corn compared to the tall corn. And so when the corn emerges from emergence through V6, you can't really tell a difference out there with the short-statured corn. Because again, the growing point isn't above the ground. It's when the growing point starts pushing above the ground, those nodes start extending, that's when you see the short-statured corn being shorter out there. And there's a good picture up here where we've got the tall versus the short-statured corn. You can see it's just a stockier, girthier plant compared to the tall corn beside it. And then also back to the applications of nitrogen, right? So strip-till is a great way to get nitrogen and phosphorus down. But looking at soil types, maybe you've got a sand or something like that, you can't put everything down. You put something down with the strip-till operation. And then with the short-statured corn, with more regular ground rigs, you can get over that. And then you can put on your micronutrient application or your nitrogen later in the season. Maybe you've got a disease that comes in, and you make a fungicide application. We have a lot of airplanes here in the U.S. that fly fungicide on our corn, but it seems like when there's a disease outbreak, everybody needs that corn sprayed with that airplane, and that makes it a lot more difficult to get a timely application. And so this will give farmers with the short-statured corn the ability with more regularly sized ground equipment to get over that, right? You only need a clearance of basically 2 meters on that sprayer to get over that short-statured corn. And so, this is a picture of the aerial application. So aerial fungicide application on tall, potential for harvest headaches from lodge corn. And so, obviously, if we've got some wind event that comes in, it pushes that corn over, and we're really reducing the efficiency of that combine going through the field and making harvest a lot longer. Versus the short-statured corn, where we got smoother harvest. Again, ground application for the fungicide, an extended nutrient application window, timely nitrogen. We all are familiar, the cost of nitrogen is extremely high. Putting some nitrogen down with phosphorus and the strip-till, coming back, making an application at V6, then making an additional application a little bit later in the growing season, because you have the ability with the short-statured corn, maybe doing some tissue testing to really look at what is that short-statured corn deficient in, and so then you can get over that and make that precise application. And so reduce risk, yield stability, reduce crop loss, and potential stress tolerance. And we're seeing some interesting things with some roots that hopefully we'll have time to look at the video here at the end. Increased opportunities, timely, precise application inputs, and potential to increase planting densities. And so, you know, we do get into this potential that, you know, as we look at, in the U.S., we're typically using 30-inch centers, which is around 60 to 70 centimeters. It basically, we can't put any more plants out there without really causing that corn plant to become spindly, right? And so then it starts really increasing lodging as we increase our population out there. But we're losing some yield potential because we're not able to push that population. So the short stature corn, we're really able to, again, a little bit girthier stalk and really be able to push that population and still have good standability at the end.
Brian, sorry, can I ask you a question there again? Sorry, you said it's planted at 30-inch. Is that at 30-inch row spacing
30
or?
Centers. Yeah.
Okay, so that's 76 centimeters. Okay.
76 centimeters. Thank you. Yep. I was doing that on the fly, so I wasn't didn't have it.
No worries. No worries.
Yep. And then we've got this vision here for the smart corn system. And I think every farmer on here knows that we've got fields that have really high input areas and fields that have low input areas. And sometimes, you know, we make recommendations for that whole field, you know, based on the average, right? Well, what if we could really go in, dial in, and maximize the yield potential on those high input areas? And so really ratchet up nutrient application, fungicide, and get the most out of those very productive pieces of ground. And that's what we're really looking at, right? So, you know, if you've got, there's probably been some talk about split planters. You know, you can put a workhorse corn product on those tough acre parts of that field, and then you put that very high productive corn product on those high yielding pieces. And then you go out there, you make that application, you get the good foundation, and then it added flexibility with in-season access to drive more precise precision and efficiency, potential for more judicious use of crop protection and fertility products, and improved water use potential, aids in in-season disease management. I think we've covered that, but again, I think timely applications are going to be one of the biggest benefits on short-statured corn. Being able to get in there when you want and apply the fungicide or insecticide to that product in a very precise manner. And then again, back to just ease of harvest, right? We look at this, and obviously, again, being able to get through that corn very quickly at harvest, it will increase efficiency. And so I wanted to take a few seconds here and ask Brian if we've got time for this video.
Yeah.
It's on the rooting structure of what we're seeing on the short stature corn. It takes about 4.5 minutes.
Yep, we have time.
Okay.
Perfect.
All righty. So hopefully let me see if the volume comes through. If it doesn't, let me know. So obviously there's the legal statements. That coming through?
No, it's not.
Okay, well, let's see here. So I will just kind of go through this frame by frame. Jeff does a great job of walking through this, but it doesn't look like we're going to be able to get the volume. So the short, we did some root pits out in Nebraska, and we've done this for multiple years, looking at tall and short statured corn, okay? And what we're seeing on below ground is pretty interesting. So the tall corn has good rooting potential, right? And you know, the roots go down about 1 meter into the soil. The shoulders on that corn plant are maybe not what we're seeing with the short-statured corn, but here Jeff is talking about, again, good fibrous root system up at the top, but then as we get lower into that soil profile, we're really missing some roots deeper down in there to extract water and nutrients out of that soil. And so then we also come over here to do a root dig on the short-statured corn. And again, you can tell we're in the short-statured versus the tall. The tall's in the back, and you can see the difference in height. And so Jeff takes us down into the root pit on the short-statured corn, and we have a much deeper and more fibrous root system that goes down into the profile. So we were seeing basically that short-statured corn going down over 1.5 meters into the soil, and sometimes up to 2 meters into the soil. And then we're also seeing broader shoulders on the short-statured corn, and really excited. And so about what this could potentially mean for the resilience of this system, right? Obviously water, some of you are in that semi-arid areas where you don't get as much water as you'd like during the growing season. So short-statured corn, you know, with this root exploration that we're seeing, we're thinking we've got a real good potential here of going out there and extracting water out of that profile. And then, Jeff continues the discussion here. Again, very fibrous root system up at the top, broader shoulders. And then I think Mick will enjoy this guy right here. So had Mike Peterson out helping with Jeff. And as everybody from Orthman knows that Mike is retired, but Mike was out there using his drawing skills, and he does a very good job of mapping out the root structure of the corn plant. And so, and then again, the tall corn is kind of a little bit shallower. Again, you can see that it's kind of topping out at about 1 meter deep versus the short-statured, where, if I can pull up the right area here, that's going deeper into the soil profile. So needless to say, we're really excited about this system. We've heard some people make some jokes about short-statured corn meaning miniature yield, and that's certainly not the case, right? We've got the same basically powerhouse of a corn plant. We're just shortening it up, and we've got great yield potential, and we're trying to give farmers an option to have the ability to put out nutrients at different timings, crop protection products, and to have that resiliency to withstand wind events that we know can be very, very devastating out in the field. And then we're, again, really excited what we're seeing going on below ground with respect to the short-statured corn. So with that, we'll go ahead and wrap it up.
Thanks, Brian. And I just want to go maybe to Willie. I know I travel a lot here in South Africa as well. You do as well. Just talking about that root structure. I know our root structure here in Africa is a little different. Willie, maybe do you know anything here? I know, like I'm giving for more existence, like in Hoopstad, Wesselsbron, Bothaville. You know, I'm talking about those areas. You know, those guys rip at least 1 meter deep just to get moisture. So they want those root structures to move down to receive that water. Willie, I don't know. You've experienced as well. I don't know. Do you do that area?
Brian, I'm in the central Highveld, so it's a bit more water where I am, but my colleagues is there in Bothaville and Bultfontein and that area. And yeah, those guys definitely, they put in big implements to get the ground loose for those roots to get down as far as possible. In my area, there's a lot of no-till and strip-till guys, again, that's utilizing the root systems that is there to get the roots down even further.
Yeah. Yeah, and then I think, I think it goes on the type of hybrid. I think, Mick, we've spoken about this as well. The type of hybrid that you use, in that strip. Brian, I don't know, am I correct in that? It all boils down to the type of hybrid you use, the fertilizer placement, the type of fertilizer you're using, and as well the equipment. And this is why we've done this as a Strip-Till conference, to bring the clients and the customers a premium product. Mick, do you agree on that?
I do, and I have some more questions for Brian Olson. Brian, number one, I guess, when can we start seeing these short statured hybrids in the field?
So here in the U.S., we're actually going to have it out on a number of farmers' field, the breeding trait, here this year. And then Willie would probably have a better idea for South Africa than myself, but it'll be in the next few years if I understand correctly.
Yes, Brian. So looking at, we already have trials in South Africa with the short stature corn. Looking at inserting the traits, or not inserting, or in creating the short stature corn with our local hybrids now. It seems like they have had some successes, so we're looking at maybe receiving trial seed next year to be able to start doing trials with the local hybrids with short corn. Yes.
Okay.
To me, I think this system of short-statured hybrids, it's going to allow us to improve nitrogen use efficiency dramatically from where we are today. We do very well where we have pivot irrigation and we can fertigate through those pivots, but there's a lot of areas where the corn is raised where maybe side dress is not used as widely as it should be in my mind as far as nitrogen use efficiency, and I see this as a way to improve that nitrogen use efficiency. And then beyond that, we know that fungicide helps improve yields, and coverage with fungicide can be huge. If we're going with a ground rig, we can go with a higher rate of volume of water as a carrier and get a better coverage there. I think that this is going to be a way that we see another leap in corn yields across.
Well, I think that's a very good way to say it, because we're really excited about the potential, and obviously we've got to get the trait, get this into our elite germplasm, right? But when we're doing comparisons, just the resiliency, I just can't come back to that enough, that it's able to withstand some difficult growing conditions a little bit better. And the wind is such can be very problematic, at least out here on the Great Plains for us.
Yeah. Mick, thank you. I'm sure you guys have done from your end, and Yapi, thanks for taking your time and spending, with us and discussing on the financial side. And Willie and Brian Olson, thank you from Bayer End. Thanks you guys for joining, and we will see you guys next time on our next episode. And Mick and I will be back tomorrow, and we've got customers that will be live with us tomorrow. And yeah, gentlemen, thank you, and we'll see you next time.